So we see here a triangle called triangle ABC, and we've talked so far about how we could transform this in a couple of ways. We could transform it by reflecting it, which is like a flip, so I could take it and I could reflect it across maybe the y-axis, which would take it and it would just flip everything over to the opposite side of the y-axis or the line of reflection. I could flip it over the x-axis and take everything, all the corners, and move them to the opposite side of the x-axis, and that would be a reflection, or sometimes I call it a flip. I could translate it, which sometimes I call a slide, which is where I just take the thing and I just slide it over by a certain amount up or down and a certain amount left or right. Right? So I could slide it by 2 units over and 1 unit up, and all 3 corners would go 2 units over and 1 unit up, and then that would give us a new location for this shape. And that one's called a translation. But the third transformation that we're going to talk about is called a rotation. And so I'm going to use GeoGebra here, and I'm going to rotate this triangle by 75 degrees about the origin. That's going to be the language I'm going to use. I'm going to rotate this 75 degrees around the origin. And so let's see what that looks like. So the first thing I'm going to do is I'm going to grab my rotation tool, rotate about a point. I'm going to select my object. I'm going to select the point that I'm going to rotate it around, which is going to be the origin. Oops, I need a point there in the origin. Let's try that again. I'm going to reflect my object around the origin, and I'm going to reflect that by, I'm going to rotate that by 75 degrees. And I'm going to rotate it 75 degrees, I'll do clockwise. And you can see this is where it ends up. And so my question is, okay, well, how is that different than a reflection? How is that different than a slide? Well, I didn't flip this thing over to get it to where it's at, right? I didn't just flip it over. A didn't just move to the opposite side of some random line, and B didn't just move to the opposite side of that same line, and C didn't just move to the opposite side of that line. There's no line that I could draw. You know, the y-axis, it wouldn't work. There's no other line I can draw that's going to just kind of be in such a place so that this thing is just flipped over that line and it became this thing. And it's obviously not just a slide either, because it kind of changed its orientation. When I do a slide or a translation, I'm not changing the orientation or the way that the thing is facing when I do that transformation. So something different happened. And if I notice, what happened is I took this A and I rotate it like imagine that it's on the end of the hand of a clock that's fixed here at the origin. And that clock hand just rotated from where it is here, and it just rotated right up here to this guy. In fact, what I'm going to do to kind of illustrate this is I am going to connect with a segment A to D and A prime to D. And remember, D is my center of rotation. That's the place where I rotated it. And so you can see what happened is this clock face, this imagine this like a hand of a clock, it just rotated from there up to there. And the same thing happened with B. It rotated from where it's at to over here. Now let's just illustrate that by connecting B to D and connecting D to B prime. And then the same thing happened with C. So let's connect C to D and then C prime to D. And in each case, all that happened is that thing got rotated. Now, if you notice, I'm gonna actually hide a couple of these segments that I just drew. I'm going to get rid of the ones connecting D to B and B prime and D to C and C prime. So I just have those original segments I drew. And I'm going to look at that, and I'm going to measure the angle AD A prime. I'm going to measure this angle right here, AD A prime. Oops, I might need to measure that in the other order. I forget sometimes what order I'm supposed to click the points on this app. And you'll notice that that angle there came out to be 75 degrees, which is the number of degrees I used for my rotation. And if I did the same thing with the other segments that I had drawn, B to D and then D to B prime, C to D and then D to C prime, those angles formed by those segments would also all be 75 degrees. And those are kind of the hallmarks of a rotation. So let's talk a little bit more about rotation. The notation, first of all, you'll see is a lowercase r so that you can differentiate it between a rotation and a reflection. Reflection gets the uppercase r, rotation gets the lowercase r. And then you see in these parentheses, an x degrees, which is how many degrees you're rotating your object, comma p, where p is called the center of rotation. So in the example I was just showing you a minute ago, that point was the origin, 0, 0, which on my picture got labeled as point D, right? So we can see here, we have this shape, ABC, that got rotated x degrees around point P, and then the new location of A was here on A prime, right? And if I connect A to P and then A prime to P, that angle measure is x degrees. And a rotation is a rigid motion, so whatever shape you create after rotating a shape, it's going to be identical to what you started with. All the side lengths and angle measures will be preserved. One thing to notice is that if we have a positive angle of rotation, that means we're actually rotating counterclockwise. It seems like it would be nice if positive meant clockwise and negative was counterclockwise, but it's actually the opposite. A positive angle measure of rotation is actually a clockwise movement. So let's look at a couple examples using rotations. So to start with, what we're going to look at is some rules for rotating by a certain, by some special, I would say, angles of rotation, 90, 180, and 270. So these are all multiples of 90 degrees of rotation. So what happens if we take a sum point, we're going to look at point B here, and rotate it by multiples of 90 around the origin. It's labeled as point A here, but a lot of times we refer to the origin as O for origin. So what happens if we rotate point B 90 degrees about the origin? So a 90-degree rotation, remember that means a counterclockwise rotation of 90 degrees. So let's go ahead and do that. Let's select my rotation tool, and we're going to rotate point B around point A, or the origin, and we're going to rotate it by 90 degrees counterclockwise, a 90-degree positive rotation. And you can see the place that it ends up is right over here. Now let's look at the coordinates of B and B prime. All right. So the coordinates of B were 2, 4, and the coordinate of B prime is -4, 2. So that's interesting. You'll notice there's a couple things that happened here. First of all, the actual numbers flipped, right? So 2 and 4, the 2 flipped spots, and then the 4 flipped spots. And then the 4 actually changed its sign as well. I wonder if that would always happen when we rotate 90 degrees about the origin. So let's try it out with another point. So what I'm going to do now is I'm going to put another point on my graph. Let's put this point at, let's put it at 4, 3. Okay, so this is a point at 4, 3. And let's rotate that guy 90 degrees around the origin. So I'm going to grab my rotation tool again. I'm going to rotate point C around the origin by 90 degrees. By 90 degrees. And you can see it put it up here, and that point is -3, 4. And so let's see, did the same thing happen? Did I switch the numbers? Yep, the 3 went from being the y to the x, the 4 went from being the x to the y, and then the x part went from being positive to negative. So it seems like I notice a pattern, that when I rotate the point 90, 0, or sorry, if I rotate the point x, y 90 degrees around the origin, the result is going to be a point that would be -y, x. I switched their spots and I flipped the sign of the first number. So I flipped in point B here, I flipped their spots. I put the 4 in the front and the 2 in the back, and then I flipped the sign of the first number. I flipped the 3 and the 4, put the 3 in the front, put the 4 in the back, and I flipped the sign of that first one. Well, what if I rotate 180 degrees? So now let's do the same, let's do the rotation of 180 degrees. So just to kind of eliminate some confusion here, I'm going to get rid of these coordinates here. I'll keep the B and C coordinates. And let's look at what happens if we rotate each of those points around the origin 180 degrees this time. So let's put 180 degrees in. So B goes down to there, and let's do the same thing with C. Again, we're going to do 180 degrees around the origin, and it goes there. Now let's label these points. So B ended up being at, we can see that's -2, -4, and C ended up being at -4, -3. And now what do you notice? Well, 2, 4 went to -2, -4. 4, 3 went to -4, -3. So it appears to me that when I rotate the point x, y 180 degrees around the origin, what I end up with is the point -x, -y. In other words, the numbers don't change spots necessarily, but they do flip both their signs, right? The 2 and the 4 stayed in the same place, but both their signs flipped. The 4 and the 3 stayed in the same place, but both their signs flipped. So lastly, let's look at a 270 degree rotation. So again, just to make things easier to kind of follow, get rid of those. And now we're going to select our rotation, and we're going to rotate point B around point A, but this time it's going to be 270 degrees. And we're going to rotate C around point A, and this time it's going to be 270 degrees. And now let's investigate these coordinates. So B is now at 4, -2, and C is now at 3, -4. So do we notice a pattern here? Well, B went from 2, 4 to 4, -2. So again, the numbers switched places, just like they did with a 90 degree rotation, but this time it was the y coordinate, or the last number, that flipped its sign. It went from being a +2 to a -2. And it seems that the same thing happened here. The 3 and the 4 switched places, and the 4 went from being positive to negative. So my rule for a 270 degree rotation seems to be that the x and the y are going to switch places, and that now the x is going to change its sign. So those are some general rules that we have for rotating by multiples of 90 around the origin. Now you'll notice I didn't put 360 in there. And let's see if you can figure out why we didn't worry about rotating 360 degrees. If you think about it for a second, I think you can come up with the reason why. Now let's take a look and see if we can put those rules that we just came up with to use in a few example problems. So to start off with, it says, what are the coordinates of the rotation of 90 degrees about the origin of the point C? So we're going to take C and we're going to rotate it 90 degrees around the origin. So my rule, if I think about what my rule was for a rotation of 90 degrees, is I take the x and the, well, first of all, let's figure out what the x and the y are for C. So C is at -3, 2. Now when I rotate that, I'm going to flip-flop the numbers, and I'm going to change the first sign. So it's going to be, I'm going to take the 2 and put it in the front, and take the -3 and put it in the back, flip-flop the numbers, and then I'm going to change that first sign. Now let's just graph that to see if it makes sense. Let's see if that looks like a 90 degree rotation. -2, -3 would be this point right down here, C prime. Does that look like a 90 degree rotation? Well, if I connect C to the origin, and then I connect C prime to the origin, yeah, that kind of looks like it's about a 90 degree angle, right? That looks like it's a 90 degree rotation. Okay, sounds good. So next, let's take a look at what happens if we rotate point F right here 180 degrees around the origin. So first of all, the coordinates of point F would be -4, -4, and our rule for a 180 degree rotation is that we just take these two numbers, we don't switch them places, we just switch their signs. So in this case, it's going to become the point +4, +4. Right? We didn't change the numbers at all. In this case, it wouldn't have actually mattered since it's the same number. But all we did was we just changed the signs from negative to positive. So let's look at that point 4, 4, and let's see, does it make sense that that might be the 180 degree rotation. So let's put point 4, 4 up here as F prime. And then again, let's connect F to the center of rotation, the origin, and connect F prime to the center of rotation. And look at that. Does that seem like it's a 180 degree angle? Yeah, it sure does. It looks like a straight line. That's what a 180 degree angle looks like. So I think that looks good. 4 comma 4 is our rotation of F, 180 degrees around the origin. Lastly, we're going to rotate G by 270 degrees around the origin. So the location of G, the coordinates of G, are 2 comma negative 3. And whereas our 90-degree rotation flipped the numbers and then flipped the first sign, our 270-degree rotation is going to flip-flop the numbers, negative 3 and then positive 2, and it's going to change the second sign. So that positive 2 is going to go to negative 2. We flip the numbers and change the second sign. So where does negative 3, negative 2 put us? Negative 3, negative 2 would put us right around here. So G prime would be here at negative 3, negative 2. And so the question we're going to ask ourselves now is, does that look like a 270-degree rotation? So if I connect origin to G and origin to G prime, this right here is 270 degrees. It's 3/4 of a full turn around a circle, or it's everything except 90 degrees. So that inside, that smaller inner angle there is 90 degrees. So yeah, that looks like 270 degrees of rotation.